Hello everyone, and welcome back to my channel, ELECTRO-MASTER. Today, I've got something super interesting for you, a neck massager, model HX5880. I've seen this device recommended for relaxation, but I thought, why not take a closer look at what's really inside? So, I'm going to take it apart piece by piece to see how it's built, what technology it uses, and if it's worth the money. Bar chart. After putting it back together, we'll move on to my favorite part, measuring the output currents for each mode using the oscilloscope. I want to see exactly what this device generates and how all the massage programs work. Bullseye. If that sounds interesting, stick around until the end, and don't forget to leave a like, subscribe, and hit the bell icon to stay updated. This device, the HX5880, is the kind of gadget that sends electrical impulses to your neck muscles, basically making them contract and relax automatically. It has several modes. For example, one simulates a relaxing massage, another mimics the sensation of acupuncture, and one tries to recreate the effect of cupping, where the pressure comes and goes, like with suction cups. If you want, you can also use it on other parts of your body, not just your neck, because it comes with separate electrodes. What's interesting is that these impulses are adjusted depending on the mode you choose, and the differences between them can be seen and measured, which is what I'll be doing later with the oscilloscope. Basically, that's what it does. It sends current through your muscles and, in theory, helps you relax or ease your pain. Enough with the studying. Now I'm going to try to take it apart without causing any damage. From these two buttons, the intensity of the electric current is controlled, allowing the power level to be adjusted from high to low, to customize the muscle stimulation according to the user's preferences. On this board, you'll find the charging connector and the electronics for charging the battery, as well as the LED that shows the battery status. The LED turns green when the battery is fully charged. On this board, there are also two buttons, one for turning it on and another for selecting the program modes. This is the main circuit, which contains a microcontroller responsible for managing and controlling the device's functions, a voltage booster, boost converter, that increases the supply voltage to ensure optimal performance, as well as switching transistors that regulate the current and voltage applied to different components. The board also includes various passive components, such as resistors, capacitors, and diodes, necessary for stabilizing and protecting the circuit. As can be seen, we have an inductor, a capacitor, and a buzzer. In this case, the inductor is part of a boost converter. The operating principle of a voltage booster that uses an inductor is based on storing energy in the magnetic field of the inductor when current flows through it. When the switch, usually a transistor, is closed, the energy stored in the inductor is transferred to the capacitor, creating a higher output voltage than the input. This process repeats rapidly, resulting in a higher output voltage, controlled by the switching frequency. I carefully analyzed to identify the type of microcontroller used, but as I can see, there is no model or information listed on it. This is quite common in certain devices, where manufacturers choose not to display details about the microcontroller in order to protect the technology and intellectual property. By omitting this information, they prevent the copying or duplication of the design, protecting the manufacturing process and internal architecture of the device. I will reassemble all the components back together, following the reverse steps of disassembly, carefully reconnecting each electronic component to the main board, ensuring proper alignment of the mechanical parts, and checking any connections or solder joints that may have been affected. In the end, I will test the device to make sure everything is working correctly. I will try to measure with the oscilloscope different waveform shapes for each program, monitoring current and voltage variations to observe the behavior of each operating mode. Each program should generate a different type of signal, such as square, triangular, or sinusoidal waves, and the oscilloscope will allow analysis of their frequency, amplitude, and waveform. As observed, each program generates currents with different waveform shapes and amplitudes, specific to each function. These variations are controlled by the microcontroller's parameters, which adjust the frequency, amplitude, and waveform type, e.g. square, sinusoidal, or triangular, for each activated program. Each operating mode influences the current applied to the electrodes, thereby altering the muscle stimulation according to the generated signal. The oscilloscope will highlight these differences in real time, depending on the selected mode. Thanks for watching until the end. If you liked it, don't forget to give a like and subscribe so you won't miss the next experiments. Stay tuned, there are many interesting analyses coming up on ELECTRO-MASTER. See you in the next video.